We flew by it at a speed of about 27,000 miles per hour, and the spacecraft was slightly below the comet in the sunplane.
Who would have thought that we actually get to see a comet close up like we just did? And when we first saw this, our mouths just dropped. Our whole team just dropped. Because we can begin to see, if you look very close to the nucleus, you can see things that are slowly moving, but then as you go farther away, they're really migrating. To me, this whole thing looks like a snow globe that you're just simply shaking and watching it fly.
When we saw the images come down, even in real time in the raw data, and realized we had a cloud of snow around the nucleus, we were astounded. Those are not stars, those are all chunks of ice. We think the biggest ones are at least the size of a golf ball and possibly up to the size of a basketball.
They're akin more to maybe a dandelion. So what that means is that the snowballs are not what we might have thought to begin with. We're not seeing softballs or even ice cubes. What we're seeing are fluffy aggregates of very small pieces of ice. While it's true that water is where the ice is, in fact it's everywhere, particularly on the sunward side of the image, to our great surprise, there's a tremendous enhancement of water vapor coming out of the waste of this body. We wouldn't expect this at all. And so what we're seeing is an indication that here the ice is still on the inside. It's being heated up by the sun, and that drives the water off.
We're still continuing to collect data. We've collected about 32,000 images of the comet since November 4th. We continue to look at it about every 2 minutes and acquire data, returning over 3,000 images a day of data. By the time we're all finished with this science mission, around Thanksgiving is our last imaging session, we will return about 120,000 images of the comet, and that represents about 22 gigabytes of data.